Welcome to Summarize Science. We often think that making AI models smarter requires massive, expensive retraining, kind of like an athlete going through an intense training camp before a competition. This process, often using a technique called reinforcement learning or RL, has been the key to the amazing reasoning abilities of today's top models. But a new paper titled Reasoning with Sampling, Your Base Model is Smarter Than You Think, asks a fascinating question. What if that intense training isn't teaching the model new skills, but just making it better at using skills it already possesses? And what if we could get that same top-tier performance without any retraining at all? The researchers propose that these incredible capabilities are already hidden inside the base models before all that extra fine-tuning. The trick is finding a better way to get the answer out of the model. Instead of simply generating a response word by word, they developed a clever method called power sampling. Think of it like a writer drafting an essay. They don't just write it from start to finish once. Instead, their method generates a complete thought, then goes back and iteratively revises parts of it, checking if each change improves the overall quality of the final answer. It's a way of exploring many different reasoning paths to find the one the base model is most confident in. This all happens at inference time, meaning when you ask the question, with no need for new datasets or costly training runs. So, how well does it work? The results are pretty staggering. On difficult reasoning tasks in math, coding, and science, this training-free sampling method performed on par with, and in some cases, even better than the heavily retrained RL models. On this table, you can see their scores. Labeled power sampling, Rs, are often higher than the RL-trained model, GRPO. But here's where it gets even more interesting. A common problem with RL-trained models is that they lose creativity, or what researchers call diversity. They become very good at giving one specific type of correct answer, but struggle to provide different solutions when asked. This graph shows what happens when you ask for multiple attempts at a problem. The performance of the RL model, the GRPO line, quickly flattens out. But the researchers' power sampling method, the Rs line, keeps finding new correct answers, showing it preserves the model's creativity. So let's recap the big takeaways here. First, the base AI models we already have possess incredible, latent reasoning abilities that are currently being underutilized. Second, we can unlock these abilities through smarter generation techniques at runtime, rather than relying solely on expensive retraining. This new method achieves state-of-the-art reasoning while also solving the diversity problem that plagues current approaches. For the future, this could be a game changer. It suggests a path to more powerful and efficient AI, where we focus on better ways to interact with models instead of just making them bigger. It's about working smarter, not just harder. Thanks for watching Summarize Science.